Hello. Now we'll do the perpendicular axis theorem. So as we did parallel axis theorem, at that time we learned that these theorems are necessary so that we can calculate the moment of inertia for a same body about multiple axes, because we cannot memorize the moment of inertia for each and every axis. Okay. So in parallel axis theorem, we made the relationship between the axes which are parallel. Okay. So in a set of axes which are all parallel, in that case we can use the parallel axis theorem. Now, in this case, as the name suggests, perpendicular axis theorem, we are going to make the relationship between the axes which are mutually perpendicular. So first thing, here we are going to make the relationship between the three mutually perpendicular axes. Okay. So I have assumed these three axes I have taken. One is along x, second is along y, and third is along the z axis. Now, before applying this theorem, there are certain conditions this theorem requires. The first condition, which is required in case this theorem to be true, is this body we are talking about. This body has to be planar. So this body has to be 2D body. We cannot apply this theorem in case of 3D object. Okay. So the body has to be two-dimensional, meaning it has to be the planar body. Okay. Second condition is regarding the axis. The three axes we are taking, those three axes has to be mutually perpendicular. The three axes has to be mutually perpendicular to each other. They are to be mutually perpendicular to each other. Third, now as you can see, out of these three axes, two are in the plane. Okay. So out of the three axes, two axes has to be in the plane. To be in the plane. And the fourth, all three axes should intersect at the same point. At same point. So if any question is following these three, any system is following these four conditions, we can apply the perpendicular axis theorem. Okay, so let's see what kind of relationship we'll be getting. So these are the three axes we are taking. One is along the x-axis, I'm calling it xx, second is yy, and third is zz. The moment of inertia about this axis I'm calling as ixx. About this I'm calling as Iyy, and about this I will be calling as Izz. Okay, so this is a planar body, and we have to it's a random body, so we have to cut an element, and the element will be cutting as a point element, because with a point element we can reconstruct any kind of body. It's a most basic element. So I've cut the point element, and the coordinate of this point element is x, y. Basically they are in the xy plane. So x, y is the coordinate of this point element. So if x, y is the this coordinate of the point element, then the perpendicular distance of this element with respect to x-axis, this axis, will be y. Perpendicular distance of this element with respect to y-axis will be x. And the perpendicular distance of this element with respect to this axis will be this hypotenuse, which is x square plus y square under root. So this is our point element. And if you can remember, the moment of inertia for the point element is defined as r square dm. This is the moment of inertia for the point element, where r is the distance of the point element with respect to axis, perpendicular distance, and the dm is the mass of the element. Okay. So there are three axes, so corresponding to those three axes we'll separately calculate the moment of inertia. Okay. So moment of inertia about x-axis, Ixx, this is the axis. So with respect to this axis, the perpendicular distance of this element is y. So moment of inertia will be integration, close integration, so that the whole body should be covered. Y square dm, because y is the distance of the element with respect to x-axis. This is equation 1. Iyy will be integration of, this is the y-axis, and the distance is x. So it will be x square dm, equation 2. Now let's go for z-axis. Z-axis is the axis which is perpendicular to the plane. So x-axis and y-axis, they are in the plane. And the z-axis, third one, is a perpendicular to the plane. So it will be integration of under root x square plus y square, because that's the distance, you see, about this axis, whole square dm. Now let's open this. Let's play with this a little bit. So this thing will become x square plus y square dm, and if we open it separately, it will become x square dm plus integration of y square dm, that is I z z. Now as you can see from the equation 1 and equation 2, equation 1, this is the value, equation 2, if you see, this is the value. So my relationship will convert into Izz is equals to Ixx plus Iyy. So this is your perpendicular axis theorem. In this theorem, if you can see, there are three moment of inertia. So because there are three mutually perpendicular axes, and the moment of inertia about the z-axis equals to moment of inertia about x-axis plus the moment of inertia about y-axis. Now we have to understand this. On the right hand side, both axes are in the plane of the body, and on the left hand side, the axis is perpendicular to the body after following these conditions. So you see, if I am having the moment of inertia in the plane, I can calculate the perpendicular one, and if I am having the perpendicular one, I can calculate the plane one. So this is the moment of inertia, this is the relationship we have to memorize. And if we memorize the parallel axis theorem and the perpendicular axis theorem, in 99% of cases we'll be able to calculate the moment of inertia about any given axis without doing the integration. Along with that, we have to memorize the moment of inertia at least about one axis for the different bodies like point mass, ring, rod, disk, etc., etc. Okay, so this is the theorem. Okay, thank you.